Viewers at home, you are welcome to my presentation on simulation. In this presentation, I will examine the meaning of simulation, uses of simulation, steps for solving problems involving simulation, and I will also provide 3 practical work examples. 3 practical work examples. Please, if you are just coming across my channel for the first time, please click the red subscribe button and also turn on the notification bell icon so that you don't miss my upcoming videos. So, what do we mean by simulation? Simulation is a modeling technique. A modeling technique that shows the effect of more than one variables changing at the same time. A modeling technique that shows the effect of more than one variable changing at the same time. Simulation is fashioned after Monte Carlo simulation. It is fashioned after Monte Carlo simulation, which is based on the idea of taking random samples from mathematical models that represent a real-life system. I said simulation is fashioned after Monte Carlo simulation, which is based on the idea of taking random samples from mathematical models that represent a real-life system. So, the use of this model involves establishing the probability distribution for each of the variables that make up the model. It involves establishing the probability distribution for each of the variables that make up the model. Uses of simulation. Uses of simulation. Number 1, for evaluating the alternative investment project. For evaluating alternative investment project. 2, for determining the optimum inventory level. For determining the optimum inventory level. 3, we also use simulation for determining the stock requirements. For determining the stocks requirements. The amount of stocks you require for your production. Number 4, for determining the optimum number of facilities in complex sequence situation. For determining the optimum number of facilities number of facilities in complex sequence situation. In complex sequence situations. These are the uses of simulation. These are the uses of simulation. I want to consider the steps for solving simulation problems. What are the steps you need to take whenever you want to solve problems involving simulation? Steps for solving simulation. Steps number 1. Determine the probability of each outcome. Determine among steps for solving simulation. The first step is to determine the probability. The probability of each outcome or event. Step number 2. Determine the cumulative probability. You determine the cumulative probability. Step number 1 is to determine the probability of each outcome. And step 2 is to determine the cumulative probability. Step 3. Use the cumulative probability to form a range of random numbers. Use the cumulative probability to form. Use the cumulative probability to form the range of random numbers. Step 4. Identify where the random numbers are feasible in the random numbers generated. Identify the where the random numbers are feasible in the random numbers generated from the cumulative probability. The last step, step number 5, obtain the optimal solution. Obtain the optimal solution to the problem. These are the steps you need to take whenever you want to solve any problems or problem involving simulation. The step 1 is to determine the probability of each outcome. That is the first step. You determine the probability, and that may be given in the question. Step 2 is to determine the cumulative probability. Cumulative probability will be determined by adding each successive probability to the preceding total probability. Step 3, use the cumulative probability to form the range of random numbers. The cumulative probability you have calculated, then you use it to form a range of random numbers. By the time we start the practical work examples, you'll be able to understand that better. Step 4, identify where the random numbers are feasible in the random numbers generated from the cumulative probability. That means you'll be given the random number in the question. You identify where it is feasible within the range. So by the time we get to the practical work, solutions or practical work examples, you'll be able to understand that. Remember, I've told you 3 different work examples will be solved. So the last step is to obtain the optimal solution to the problem. Now, example. Example 1. This question is obtained from the study test of the Institute of Chartered Accountants of Nigeria, EZIKAN, by Emily Wolf International. A company makes 4 styles of one of its products. The demand for these products is as follows. We have the type and the probability. Economy, the probability of 0.15. Normal, probability of 0.42. Super, the probability of is 0.28. Deluxe, and the probability of is 0.15. Use the following random numbers to stimulate the next 7 demands. I've told you earlier that random number is usually 2 digits. So meaning that 25 is one random number, 95 is another, 32 is another random number, 84 is another one, 10 is another random number, 72 another random number, and 66. If you count it, how many random numbers altogether? 1, 2, 3, 4, 5, 6, 7. And that is why you were asked to simulate the next 7 demands. The next 7 demands. Now, solution. I've told you that to solve a problem, the first thing is to assign random number to the type of the product. You know, you have economy is the first one, economy. Then the second one is normal. The third one is super. The fourth one is deluxe. And to each of these, the probability were assigned. The probability assigned to economies is 0.15, and that of normal is 0.42. So we have 0.15 is 0.42. Then for super, we have 0.28, and for deluxe, we have 0.15. 0.28 and 0.15. The next thing is to determine the cumulative probability. Cumulative probability. So you have 0.15. 0.15 plus 0.42. 0.15 plus 0.42, that will be 0.57. 0.57. 0.57 plus 0.28. We have 7 plus 8, that is 15. 5 plus 2, that is 7 plus 1, that is 8. That is 0.85. 0.85 plus 0.15, that will be 1.00. Then that is your cumulative probability. Then you now assign random number based on your cumulative probability. You assign random numbers based on your cumulative probability. We have random number. So you have to decrease, you start from a 0. You have to decrease this 15 by 1. Let's assume everything is a whole number. Let's forget about decimal points. Let's start from 0, 0. You start from 0, 0 to, if you decrease 15 by 1, then you have 14. That means it will be from 0, 0 to 1, 4 to 14. Then, see this one ended at 14. The next one will immediately start from 15. So we have 15 to, if you decrease 57 by 1, you have 56. Then since this one ended at 56, then the next one will start from 57. 57. If you decrease 85 by 1, you have to 84. Then the next one will start from 85. 85 to, you know, this is 100. If you decrease your 100 by 1, then you have 99. That is your random number. Then you want to stimulate your demand. Then let's have the production run. Your production run, you want to stimulate the demand. Your production run, so you know you have to have 7 demand. 1, 2, 3, 4, 5, 6, and 7. These are your production run. Then your random number follows. Random number. You know, the first random number is 25. So, that is your first production run. You assign that 25 to your first production run. The second one is 95. That will be assigned to the second production run. The third one is 32. You assign it to the third one. Then the next one is 84. Then followed by 10. Followed by 72. And finally, we have 66. These are our random numbers. Now, the next thing is to check where these random numbers can be feasible here. Where they can be feasible. The first one is 25. You cannot obtain 25 between 0 and 14. But 25 will fall between 15 and 56. That means 25 is in between this range. Since 25 is in between this range, then that means it is feasible here. So at this range, you have the number. That means simulated demand. Our simulated demand. So since 25, the first random number, since it is feasible here, then that means you have the number. The demand on the first production run will be normal demand. Then the second random number is 95. 95 will be feasible between 85 and 99. You know, 95 is in between 85 and 99. So that means you are going to have the deluxe. Deluxe will be the simulated demand. Deluxe. Then the next random number is 32. 32 can be obtained between 15 and 56. It lies between 15 and 56, and that is also normal. Normal demand. The next random number is 84. 84 is obtained here, and that is for super. Super. Then the next random number is 10, and that 10 can be obtained between 0 and 14. It lies in between that range. Then you have the economy as our demand. Then the next random number is 72. 72 lies between 57 and 84. And the demand at that range is super. Super. Then finally, the last random number is 66. And 66 lies between 57 and 84. It falls between this range. And the demand at that range is super. So these are the simulated demand. That is the solution to the first work example. That is the solution to the first work example. Example 2. This question is obtained from ACC study test F5 performance management by Kaplan. The MP organization is an independent film production company. It has a number of potential films that it is considering producing, one of which is the subject of a management meeting next week. The film, which has been code-named CA45, is a thriller based on a novel. A thriller based on a novel by a well-respected author. The expected revenue from film have been estimated as follows. There is a 30% chance it may generate total sales of $254,000. 50% chance sales may reach $318,000, and 20% chance that 20% chance they may reach $382,000. Expected costs: advertising, promotion, and marketing have also been estimated as follows. there is 20% chance they will reach approximately $248,000. 60% chance they may get $260,000, and 20% chance of totaling $272,000 required. Use simulation method. Use simulation method to provide forecasts of possible profits, or losses under 5 different circumstances. You may use the random number given below for the revenue and cost. You have 98, 12, 56, 02, 38, 66, 77, 55, 63, and 98. You have to use this random number to simulate 5 different circumstances. You have the 5 circumstances to simulate now. So after that, simulation, we usually have 2 random numbers based on Monte Carlo simulation. Monte Carlo simulation, I've told you, is a system of random numbers. The first random number, 98, will be for revenue. Y12 will be for cost. 56, revenue. 02, cost. 38, revenue. 66, cost. 17, revenue. 55, cost. 63 for revenue. And 98 for cost. If you count the number of revenue now, you'll be having 1, 2, 3, 4, 5. And the number of cost, you'll be having 1, 2, 3, 4, 5. That means you have 5 circumstances for revenue and 5 circumstances for cost. That is why you were asked to simulate, to provide forecasts of possible profits or losses under 5 different circumstances. Remember that profits is the difference between revenue and cost. That means you will need to simulate your revenue. Then you will also find the forecast, you will need to determine the forecast revenue as well as the forecast cost in those 5 different circumstances. Then after which you match your cost against revenue to determine the profits or losses for the period. Where this forecast revenue exceeds the forecast cost, that means you have the profit. That means there is a profit. And where the forecast cost exceed the forecast revenue, that means losses have been incurred. Now, let's have the solution to the question. The name of this entity is MP. That is the name of this entity, MP. MP organization. Now, let's have MP. Now, let's simulate let's first of all assign a random number. Let's determine our random number first. So now let's have for revenue now. Let's start with revenue. I've told you that simulation is a system of random number. So we have our revenue, simulated revenue, or assign random number to our revenue. Assign random number. Let's assign random number to our revenue. So now we have our revenue, then you have the probability. Revenue and probability. Now, let's go to where you have revenue detail. The expected revenue from film have been estimated as follows. There is a 30% chance it may generate total sales of $254,000. So our first revenue is $254,000. That is, you have 30% chance. That means the probability of 30%, 0.3. 30% chance it may generate total sales of $254,000. 50% chance sales may reach $318,000. Then at the probability of 0.50, then you have the estimated revenue to be 318,000. 318,000. Probability of 0.50. Then, and 20% chance they may reach $382,000. 20% chance of having $382,000 as revenue. That is the revenue and the associated probability. Then the next one is to assign random number to our estimated revenue. I've told you that to assign random number, before that, you will need to determine the cumulative probability. Cumulative probability. So the first one you have is 0.30. 0.30 plus 0.50, you have is 0.80. 0.80 plus 0.20, then you have 1.00. So that is our cumulative probability. After the cumulative probability, the next thing is your random number. Random number based on Monte Carlo simulation. So I've told you that you start from 0, 0, then you decrease 30 by 1, then you have 229. That means the next one will start from 30. You decrease your 80 by 1, then you have 79. Then the next one will start from that 80 and decrease 100 by 1, then you have 99. That is our random number. Now, having assigned the random number to our revenue, the next thing we want to determine our forecast revenue. The next thing is our forecast revenue. Forecast revenue. Forecast revenue. So, you are to provide a forecast of possible profits or losses under 5 different circumstances. So that means you are going to have 5 circumstances. Now, circumstances number, let me have 5, 4, 3, 2, and 1. These circumstances. Then we have our random number. Repeat those random numbers that are for revenue. The random number that are for revenue, we have 98, 56. Let's have that. 98, 56. The third one, we have 38, 17. 38 and 17. The last one is 63. 63 is the last random number. Now, let's have our forecast revenue. Forecast revenue. Our forecast revenue based on our random number. The first random number is 98. And 98 is feasible between 80 and 99. It lies between 80 and 99. That means the simulated revenue will be $382,000. 382. The second random number is 56. And 56 lies between 13 and 79. That means the simulated revenue will be 318,000. 318,000. The third random number is 38. 38 lies between 13 and 79. And that means our simulated revenue will be 318,000 as well. 318. The fourth random number is 17. 17 is feasible between 00 and 29. That means the simulated revenue will be 254,000. 254. And the fifth random number is 63. 63 lies between 13 and 79. That means our simulated revenue will be 318,000. 318,000. That is the simulated revenue. The next thing is to assign random number to cost. Step 2. So we assign random number to our cost. Assign random number to cost. So we have our cost and the probability. Now let's read the cost details. Expected cost: advertising, promotion, and marketing have also been estimated as follows. There is 20% chance they will reach approximately 248,000. 248,000 as cost, then the probability is 0.2. 248,000, probability of 0.2, which is 20%. Then the next one, 60% chance they may get 260,000. At 260,000 cost, the probability is 0.6. 260,000. We have 0.6. And 20% chance of totaling 272,000. 272,000 cost, probability of 0.2. Then the next thing is the cumulative probability. Cumulative probability. We have 0.2. 0.2 plus 0.6, that will be 0.8. 0.8 plus 0.2, that will be 1.00. Then we have our random number. So you start from 0. If you reduce 20 by 1, then you have 19. Then the next one will start from that 20. Then decrease your 80 by 1, we have 79. The next one will start from 80. Then you reduce 100 by 1, then you have 99. That is the random number. Having done that, let's have the forecast cost. Forecast cost under 5 different circumstances. Let's have circumstances number 5, circumstances 4, 3, 2, and 1. So 5 different circumstances. So then you have the random number. The random number associated with cost. The first one is 12. The second one is 0.2. Then we have 12. We have 0.2. The third one is 66, while the fourth one is 55. 66 and 55. And the fifth one is 98. 98. Now let's have our forecast cost. So forecast cost. The first random number is 12. And 12 is feasible between 00 and 19. 12 is feasible between 00 and 19. So that means the forecast cost at that level will be 248,000. The next one is 02, which will as well be feasible between 00 and 19. Then you have 248,000. The third one is 66. And 66 will be feasible between 20 and 79. So you have 260. The next one is 55. And 55 will as well be feasible between 20 and 79. Then you equally have 260. Finally, the last one is 98. And 98 is feasible between 18 and 99. Then you have 272. These are the forecast cost. Forecast cost. Now, having done that, you now go back to the requirement. You are to use simulation method to provide forecasts of possible profits or losses under 5 different circumstances. So remember, profit equal to revenue minus cost. That means you want to determine the forecast profits or losses. Forecast profits or losses under 5 different circumstances. So now let's have circumstances number 5, number 4, number 3, number 2, and number 1. These are the 5 different circumstances. All amount in thousands dollar. Now, what is our forecast revenue? Forecast revenue. Our forecast revenue. That is the first thing. Our forecast revenue. So, if you go back to our revenue details, you have 382, 318. Let me put down that 382. This is our forecast revenue. 382, 318, 318. The next one, you have 254 and 318. 254, 254, 318. That is our forecast revenue. Then the next item is the forecast cost. Forecast cost. Forecast cost. Now, let's go back to our simulated cost. We have the forecast cost to be 248, 248, 260. 248, 248, 260. Then we also have 260 and 272. 260 and 272. Now you match your cost against your revenue. You match your cost against your revenue to determine the profit. So our forecast profit now will be 382 minus 248, and that will give us 134. Then if you have 318 minus 248, that will give us 70. If you also have 318 minus 260, and that will give us 58. If you also have 254 minus 260, that will give us minus 6. That shows that this is a loss. Then, if you also have 318 minus 272, that will give us 46. That is our forecast profit or losses. Losses in bracket. So that is the solution to example 2. So the next work example shall involve the calculation of the net present value. Example 3. The following probability estimates have been prepared for a proposed investment project. Year, probability, and the amount in naira. We have the initial outlay in year 0 and the probability of 1, and the amount is 40,000 naira. Revenue per annum from year 1 to 5. At the probability of 0.15, we have 40,000 as revenue. Probability of 0.40, we have the revenue of 50,000. And at the probability of 0.30, revenue is 55,000 naira. And at the probability of 0.15, revenue is 60,000 naira. We equally have the running cost per annum for year 1 to 5. At the probability of 0.40, the running cost is 25,000 naira. And at the probability of 0.25, the running cost is 30,000 naira. And at the probability of 0.35, the running cost is 35,000 naira. We have the cost of capital. Cost of capital is 12% required. Analyze the risk inherent in this situation by simulating the net present value calculation. You should use the random numbers given below. You should use the random numbers given below. We have the random numbers. Then we have for set, we have revenue, running cost. For set 1, the random number associated with revenue is 13, and that of the running cost is 71. For set 2, the random number is 20 associated with revenue, and the one associated with the running cost is 00. Then set 3, the random number is 79 associated with revenue, and the one associated with the running cost is 94. So that is the question. We therefore want to provide solution to the question. Solution. So remember the steps. The steps I've given to you. The first step is to assign random numbers to revenue. Step 1. Assign random number. Assign random numbers to revenue. We have revenue. We have the probability. So, revenue and the probability. The first revenue is 40,000 naira, and its associated probability is 0.15. Revenue of 40,000 with the probability of 0.15. Then we also have revenue of 50,000 with the probability of 0.40. We as well have revenue of 55,000 with the probability of 0.30. 55,000, probability of 0.30. And finally, we have revenue of 60,000 with its associated probability of 0.15. 60,000 and 0.15. The next procedure or step is to calculate the cumulative probability. Cumulative probability. So the first one is 0.15. 0.15 plus 0.40, then you have 0.55. 0.55 plus 0.30, then you have 0.80. 0.85. 0.85 plus 0.15, then you have 1.00. Then with this cumulative probability, then you assign a random number. I've told you that you start from 0, 0, you decrease the 15 by 1, then you have to 14. Then this one, the next one will start from 15. Then you decrease 55 by 1, then you have 54. The next one will equally start from 55. If you decrease 85 by 1, then you have 84. The next one will start from 85. This is 100, and if you decrease that by 1, then you have 99. That is the random number. Now, back to the question. You are given the random number for 3 sets. 3 sets of cash flows. There are 3 sets. You have the random number associated with revenue for set 1, set 2, and set 3, where we have 30, 20, and 79. Now, let's have simulated revenue. Simulated revenue. We have 3 sets. Set 3, set 2, and set 1. Then we have our revenue. So these are the 3 sets. Let me have sets. These are the 3 sets we have. Then the next thing is the random number. Random number. The random number associated with revenue. Set 1 is 30. Set 2 we have 29. And set 3 we have 79. 30, 20, and 79. That is the random number associated with revenue. Now we have 30, 20, and 79. These are the random numbers associated with the revenue. Then, with this random number, we want to identify where these random numbers are feasible from the random number established from our cumulative probability. So the first one is 30. And 30 lies between 15 and 54. 30 lies between 15 and 54. And the revenue at that level is 50,000. So that means forecast revenue now. Our forecast revenue, the first one is 50,000. That is at the random number of 30, which lies between 15 and 54. The revenue at that level is 50,000. Then the second random number is 20. 20, where can the 20 be obtained? It still falls within the same range. It still lies between 15 and 54. That means the revenue at that level, the simulated or the forecast revenue, will be as well be 50,000. The third random number is 79. 79 lies between 55 and 84. And the revenue within that level is 55,000. So we have our forecast revenue to be 55,000. That is the simulated revenue. The next thing is to assign random number to our running cost. Assign random numbers to running cost. So we have our running cost. Running cost. We have the probability of the running cost. And what are the running costs given in the question? Back to the question. We have the running cost for year 1 to 5. Running cost for year 1 to 5. Running cost for year 1 to 5. So, at the running cost of 25,000, the probability is 0.40. Running cost of 25,000. Probability is 0.40. Then we also have running cost of 30,000. 30,000. The probability is 0.25. At the running cost of 30,000, probability of is 0.25. Finally, we have the running cost of 35,000 with the probability of is 0.35. 35,000, probability of is 0.35. The next thing is to calculate the cumulative probability. Cumulative probability. The first one is 0.40. 0.40 plus 0.25, that will be 0.65. 0.65 plus 0.35, that will be 1.00. Then, with this cumulative probability, you assign the random number. Now, let's have our random number. Random number. So, you start from 0, 0. The last, you decrease 40 by 1, then you have 39. Then that means the next one will start from that 40. Then you reduce 65 by 1, then you have 64. The next one will start from 65. Then if you reduce 100 by 1, then you have 99. Then, from this random number, you want to simulate the running cost. Simulated, or let me have the forecast running cost. So let's have simulated running cost. Then we have 3 sets. Set 1, set 2, set 1, set 2, and set 3. Then we have the random number. Now, we have 3 random numbers associated with the running cost. We have 70, 00, and 94. The first one will be 71. 71, 00, and 94. What will now be our forecast running cost? Now, the random number of 71 is feasible between 65 and 99. That means the running cost will be 35,000 naira. And the random number of 00, that 00 lies between 00 and 39. So the running cost will be 25,000 naira. And the last random number is 94, which also lies between 65 and 99. Therefore, the running cost will be 35,000 naira. The next thing is that we want to determine our net cash flows for the purpose of our net present value calculation. We want to determine the net cash flows for the purpose of NPV. Net cash flows. So, net cash flows. So, we have 3 sets. Set 3, set 2, and set 1. So we have revenue, forecast revenue. Forecast revenue. Our forecast revenue is 50,000, 50,000, 50,000, and 55,000. 50,000, 50,000, and 55,000. The next thing is the forecast running cost. Forecast running cost. Our forecast running cost is 35,000 naira, 25,000 naira, and 35,000 naira. Forecast running cost. Forecast running cost. Forecast running cost 35,000 naira, 25,000 naira, and 35,000 naira. You now subtract the forecast running cost from our forecast revenue to get the net cash flows. Forecast running cost minus forecast revenue will give us the net cash flow. 50,000 naira minus 35,000. Then you have 15,000. That is our net cash flows. 50,000 minus 25,000. That will give us 25,000. Then we also have 55,000 minus 25,000. That will give us 20,000 naira. Now, having get our cash flows, the next thing is to calculate the net present value. Calculation of expected net present value. Calculation of the expected net present value. Remember, we have three sets. Let's have for set 1. Set 1, you have year, then you have the cash flows, then you have the cumulative discount factor at, you are given the cost of capital of 12%, then the present value. Now, if you go back to the question, you have the initial outlay to be 40,000 naira. Initial outlay is 40,000 naira. And the cost of capital is equally given to be 12%. So, initial outlay, which will be year 0, we have the 40,000 as our outlay. The cost of capital is 12%. For year 0, it will be 1. The present value will be 40,000 times 1. That will give us 40,000 naira. Then, if you look at the cash flows, both the running cost and the revenue is for year 1 to 5. Year 1 to 5. That means the cumulative discount factor you will use will be for year 1 to 5. So, we have year 1 to 5. Then, for set 1, the net cash flows for set 1 is 15,000 naira. 15,000 naira. What is the cumulative discount factor for year 1 to 5 at 12% cost of capital? Now, to calculate the cumulative discount factor, you use the annuity formula, which is 1 minus 1 plus r raised to power minus n over r. So, which will be 1 minus, the r is 12%, which is 0.12, plus 1, that will be 1.12 raised to power minus n. The number of years, 5 years, all over r. Our r is 12%, which is 0.12. And if you make use of your calculator, therefore the cumulative discount factor for year 1 to 5 is 3.6048. 3.6048. That is the cumulative discount factor for year 1 to 5. Now, 3.6048. That is the cumulative discount factor. Then 15,000 naira times 15,000 naira times 3.6048, and that will give us 54,072. 54,072 minus 40,000, then you have 14,072. That is our expected net present value. Then you do the same thing, similar thing for set 2. Set 2. You have here, you have the cash flows. Year 0, the outlay still remain 40,000 naira. Then year 1 to 5, the net cash flow for set 2 is 25,000 naira. Then you have 25,000 naira. Then cumulative discount factor at 12% cost of capital. Year 0 will still be 1. Then year 1 to 5 still remain 3.6048. The same value you've obtained earlier. Then the present value, 40,000 times 1 will be 40,000. 25,000 times 3.6048. That will give us 90,120. If you subtract 40,000 from 90,120, then you have 50,120. That is our expected net present value for set 2. Then we also have set 3. We have here, we have the cash flows. Year 0, the outlay still remain 40,000. Cumulative discount factor at 12% cost of capital. For year 0 will still be 1. Then year 1 to 5, the net cash flows for set 3 in year 1 to 5 is 20,000 naira. Then you have 20,000 naira. Cumulative discount factor for year 1 to 5 still remain 3.6048 as calculated earlier. So what will that be the present value? 40,000 times 1 will still be 40,000. 20,000 times 3.6048. That will give us 72,096. 72,096. Therefore, the expected net present value, if you subtract 40,000 from that, then you have 32,096. So, the next thing is to calculate the expected net present value for the overall project. You calculate the expected net present value for the overall project by calculating the simple average. You calculate the simple average of the expected net present value of 3 sets of cash flows. So, expected net present value of the project is equal to the simple average. That is, the set 1, you have the expected net present value of 14,072. 14,072 plus, for set 2, you have 50,120. 50,120. And for set 3, you have 32,096. You now calculate the simple average of the 3. Since there are 3 sets of cash flows, then you divide your expected net present value by 3. Therefore, the expected net present value of the project is 32,096. 32,096 naira. If you add 14,072, 14,072 plus 50,120 plus 32,096, the total will be 96,288. And if you divide 96,288 by 3, it will give us 32,096. That is all about simulation. In this YouTube channel, you'll be seeing lectures from time to time, as well as some comedy video. Please turn on the notification bell icon. Also subscribe to for my upcoming, so that you don't miss my upcoming videos. Thanks.